That's so pretty.
It's the fine arts meeting, Mr. Brand.
How am I supposed to know that?
Well, she's excused.
Says who?
Miss
You?
Roberts.
Who?
Miss Roberts.
She didn't send me anything.
Uh-oh, she's skipping.
Roll.
Am I able to get this one?
Which one? Oh, brand new?
Before.
Okay. It's, what's the symbol? Can you hand me a yellow sheet just so I make sure I get the symbol correct?
Yeah.
Brand
Are they like right out of school?
B.
Because they're 30 to what?
There you go. You're welcome.
Because I need to be like
I
at
don't know,
home
I
by
haven't
5.
started on.
So I don't know when to
Can we just add them up? Cause 10,
like
28.
30 when surgery and both.
I got G.
I didn't make this period because I was bored. But, and then I got something. Yeah.
What? You come here.
Certainly.
Okay, for the fourth one. With the element. So
Yep.
the texture page is gonna be this one, the 14.
Okay.
But then it's this, the half filled, so then I could be like the third one down.
Same period as the half-filled d orbitals. How many electrons filled with these? Nope. That'd be the p's.
Oh, so it's 5.
D10. So
Okay,
it's
so
gonna be
that's
five.
half of it. So fifth period, you got the family. Where do the two line up?
So it's gonna be 50, that's it.
If that's the fifth period in the 14th group, yes.
Okay.
Yep.
Oh my god. So for the last one, if one of them isn't on like the list that you gave us, should we go to the next one over?
Correct.
Okay.
But those two are on your list.
What?
They are.
With the lowest wavelength.
Longest, not lowest.
Oh,
longest.
Oh yeah.
Okay. I'll give you one more minute, ladies and gentlemen, then we'll go over them.
Would an F suborbital be 6?
Would an F suborbital be what?
7?
Well, the F suborbitals do fill in the 6th and 7th periods, yes. Okay, ladies and gentlemen, let's go through it. The first one, we give you the K, L, the M, the N. Now, there are multiple ways you can do this. The easiest way, not the only, but the easiest way is this. What's the last energy level being used? What? The fourth. And how many electrons are in it? 4. Fourth level, 1, 2, 3, 4.
Yeah, or you can just count.
Or you can add them up. 2 and 8 is 10, plus 18 is 28, plus 4 is 32. You get to the same element either way. Questions? You will not end in a D or an F, so you do not have to worry about that. Okay? All right. Has a -3 charge when stable. What family has a -3 charge when stable? The nitrogen family. And is the nonmetal with the lowest ionization energy. So in the nitrogen family, these are the 3 nonmetals. Which one has the lowest ionization energy? The one at the top or the one at the bottom? The one at the bottom, astatine. Very good. Questions?
Isn't it arsenic?
What did I say?
Acetine?
No, astatine is AS. Mr. Brand? Yep. Wonderful. They're working on practicing for their test. She's taking her final. Yep. Not going to happen. Sure, we'll do. Okay. Bye. Yep, bye. Okay. So,
It's arsenic. Trust.
what's that?
It's arsenic.
Yes, you're right. I'm sorry. It is arsenic, not astatine. Thank you. Good job, Cynthia. This salt former is a liquid at room temperature.
We are.
Bromine. Very good. Bromine, Br. This element is in the family that has a tetrahedral shape and sp3 hybridization. Now, I don't have to tell you sp3 hybridization because the only way you can have sp3 hybridization is to be a tetrahedral. But what family are we talking about? The carbon family. And it's in the same period as a half-filled d orbitals. Now, again, how many electrons fill the d orbitals? 10. Half-filled would mean 5. Carbon family, period 5, 2, 3, 4, 5. That would be where tin is, 50. Questions? Okay, now for the one that will be exactly like on your test. These two elements named for the forms of visible light with the longest wavelengths. Tell me what those forms are. Red and orange.
Yeah.
Which one is longer?
Red.
Red. Okay, good. So now we know that. Are next to each other in the period for the number that represents an F suborbital. What period or what number represents an F suborbital? Not 7, no. That's how many suborbitals there are, or orientations there are.
Oh, then 3.
3. 0 represents the S, 1 represents the P, 2 represents the D, 3 represents the F. So we are in the third period somewhere. Okay? And even though they are next to each other, so that means that literally they need to be side by side. The one with the shorter wavelength, which one has the shorter wavelength? Orange, has a larger atomic radius, but a smaller ionic radius than the one with the longer wavelength. What is the only way that two elements can be right next to each other and one have a larger atomic radius but smaller ionic radius? Non-metal and a metal. So, right here, metal, here, non-metal. This one has the smaller ionic radius, larger atomic radius, so that would be orange. There would be red.
Oh.
Questions?
Wait, how did you find the F suborbital? How did you find what period that was?
Because remember, in quantum numbers are all numbers. The second quantum number, which represents the S, the P, the D, and the F, go 0, 0 and 1, 0, 1 and 2, 0, 1, 2, and 3. 0 represents an S suborbital, 1 represents a P suborbital, 2 represents a D suborbital, and 3 represents an F suborbital. So that's why the third period. Okay. It has to be both of them touching the bold zigzag line, because that's the only way where they can be next to each other, and one can have a larger atomic radius but smaller ionic. Yes?
Okay, so then what are the ones where like the S represents a 1, the P's are a 3, the D's a 5, and the F is a 7?
Okay, that's how many orientations there are. There's one orientation of an S, there are 3 orientations of a P, 5 orientations of a D, 7 orientations of an F.
That's like the halves. Right?
Correct, that's the halves.
The half.
Every orientation can hold 2 electrons. So you can figure out the orientations by taking the total number of electrons in that area and dividing it by 2. Or you can simply know those numbers, however you prefer.
The suborbitals are the energy levels?
No. Energy levels are these. The suborbitals are within the first energy level, there's just an S. In the second, there are S's and there are P's. In the third, there are S's, D's, and P's. In the fourth, there are S's, there are P's, there are D's, and there are F's. Okay? And we never go larger than the F sublevel. We never go larger than 4 sublevels in any energy level. The fifth would technically have 5, but we don't need the fifth, so we never talked about it. An F. What energy sublevels are in it? An S, a P, a D, which are 1 behind, and an F, which are 2 behind.
But wouldn't the F start at the
F's
sixth?
start in the 6th energy level. F's exist in the 4th, fill in the 6th.
Oh, okay.
S's exist in the 3rd, fill in the 4th.
Well, how do F's exist in the 4th?
Because that's when the energy level becomes large enough that you can have 4 energy sublevels.
Okay.
In the first level, there's only 1 sublevel. In the second, there's 2. In the third, there's 3. In the fourth, there's 4. So the 4th sublevel exists in the 4th energy level. But because of that energy game over there with electrons filling at the lowest energy first, the F's fill 2 behind. So the 6 S's fill before the 4 F's.
Yeah.
The 4 S's fill before the 3 D's. The D's are only one behind. Okay? Good. Questions?
So that side is non-metals besides noble gases.
Well, the noble gases are non-metals.
Oh, so that whole side is non-metals?
Correct.
Okay.
Anything on this side of the bold zigzag line, and including hydrogen.
Okay.
Good. Any other questions? Okay. I need about the last 30 minutes to go through the answers with you on practice table 1. So you've got about 20 minutes, ladies and gentlemen, to continue to work on it. Continue to get as much of it done as you can. And at about 10 till, ladies and gentlemen, we will start going over it, and I will give you all of the answers and explain any clues you do not understand. So, questions? Okay, please go to work. Okay, let's go through this, ladies and gentlemen. If you have any questions, I will be happy to explain things as we go. Okay, but we need to get moving if we want to get done today. Okay. Elements A, F, K, P, U, Z, Z, E, E, and J, J are all third period elements. So if you get a clue like this, my suggestion is to put them next to the period or the group that you are talking about. By the way, I have found today that people struggle just understanding what a period in a group is. Because it'll say it's in the same period as something and they will put it somewhere completely different. Periods go across the periodic table. Families or groups go up and down. Okay? So keep that in mind. Also, if I give you a clue like this, I'm not going to leave you hanging. I'm not going to wait a long time before I start to put those into place. There are times where one element will depend on another one that you place. So if you decide to skip something, that may hurt you later on down the line. Okay? But again, you got to do what you got to do. F is the most reactive metal in its period. Now, people tell me, Mr. Brand, francium is the most reactive metal. That is true. It didn't say the most reactive metal on the table. It said the most reactive metal in its period, which means it goes there. And then ZZ is the most reactive nonmetal, which means it goes there, ladies and gentlemen. Cross them off when you're done. K reacts slightly with water to form a base. The alkaline earth metals react slightly with water. The alkali earth metals react strongly with water. EE can be a +4, -4 ion. That means it has to be in the carbon family. AA has, an atom of JJ is larger than a P atom, but a JJ ion is smaller than P. So what that means, ladies and gentlemen, is that JJ has to be on the metal side. Now, I can put JJ here. What I can't do is put PP because I don't know where it goes yet. It's got to be in one of these 3 spots, though. Luckily, the next clue says P combines with F to form F2P. What's the charge of F? No, it's not a -1. +1. And since there are 2 of them, the total charge is a +2. What does the total charge of the P need to be? -2. And how many of them are there? So what number times 1 gives us -2? -2. So P has to be here in the family where it would be a -2. Questions? All right. That leaves me with A and U. A has a full valence shell of electrons. Means it's a noble gas. Means U has to go right here, ladies and gentlemen. Didn't give you any other clue to put U in other than it's the last one remaining. Questions? All right. Element B has the highest ionization energy of any element. What spot? Top right, helium. Element C has the highest electronegativity of any element. What spot? Okay, where fluorine is, because, ladies and gentlemen, we don't count the noble gases in electronegativity because they don't have a tendency to attract and hold on to an extra electron. They don't do that. Okay? D is the most metallic of any element. That goes down in this corner. E is an unreactive gas that is radioactive and has electrons that fill the f orbitals. That means it could be down here, 6 or 7. I don't know which yet. G is also an unreactive gas that is man-made. Okay, when I put G in here, the only place left for E is right above it. Questions? L is the lightest of all elements and can gain and lose an electron. That's hydrogen. M is a fourth period element with 1 valence electrons. Here's the fourth period. Here's where there is 1 valence electron. That is a no-brainer, ladies and gentlemen. You get that wrong, you are going to struggle all the way through this test. N is in the same family as M, but is more reactive. What does that mean for N? It's somewhere below it. There are 2 spots here. I don't know which one yet, so I'm going to put it in between them. O has a larger atomic radius than T. Both O and T are alkali metals. So O and T need to go in this family as well. Which one goes further up? T has to be above O. If I put O here, I could put T here, but what's wrong with that? I don't have any room for N. So what does that mean? That T has to go up here so that I could put O in one of these 2 spots because it will still be larger than it. N has a lower ionization energy than T. N goes on the bottom. I'm sorry, then O, my mistake. O goes on the top, ladies and gentlemen. Questions? So again, I got you where you got clues in between a couple of areas, and then I ask a question that sorts that out for you. That's what you can expect on the test as well. Declan.
What does it mean it has like a lower ionization?
Ionization energy is the energy needed to get it to give up an electron. And as you go down the periodic table, ionization energy decreases. Questions? AA, BB, CC, and DD in increasing order of mass are in the same family as P. Which way do P's go? Which way do families go? Okay, so to have a larger atomic mass than P, they need to be where? Okay, what happens to mass as you go down? So the order that they are in, AA, BB, CC, and DD is the exact order that you put them in here. Now I could see that being like 4 types of visible light, putting them in order of their wavelength or frequency or energy. Right? Okay. II is a 4th period nonmetal that is considered to be a metalloid. What does that mean? It's what? It's on the zigzag line. There's only one spot on the zigzag line where it would be a nonmetal and a metalloid. FFGGHH, arranged in increasing ionization energies, are all 4th period metals. 3 4th period metals left. What happens to ionization energy as you go across? It increases. So therefore, FF, GG, HH are in order of increasing ionization energies. KK is an inert gas and has no d orbitals. When do d orbitals start? 4th. There's only one spot where you can be inert and no d's, and that is the 2nd period. Now, it could have been the 1st. It could have even been the 3rd, but those were taken. LL is a halogen in the same period as G. Where are halogens? 17. Same period of G means down here. I had a person who struggled with that this morning. Why? Well, periods go up and down, right? No, they don't. Periods go across. Okay? Z minus 1 has the same number of electrons as E. So where is our -1 family? So Z has to be right next to E because when it gains 1 electron, ladies and gentlemen, it will look just like E. O plus 1 is isoelectric to W. Well, where's W? It's not, but what is? And metals are isoelectric to the noble gas where? The row above them or before them. So that's where W goes. X is a second period element that reacts with K to form KX. Second period element. All right, where's K? What's its charge? +2. So what has to be the charge of X? -2. Y is one of the elements found in the last family of elements to be discovered. What was the last family to be discovered? The noble gases. MM is in the same period as BB and needs only one more electron to fill its outer shell. What does that mean? It's closer to the noble gases. Here is the spot where you only need to gain 1 electron to fill up. Q, R, and S, arranged in order of increasing atomic radii, are 6th period elements. 6th period elements in here, right? Okay. Did I miss something, ladies and gentlemen? I'm sorry, I missed the NN and the PP question. Sorry.
Wait, could you explain why J and X are?
Yes. J and S. I gotta find
X.
which
Like X.
What?
Where we put J.
X here.
Yeah.
Okay, well, it's got to be in the second period.
Yeah.
And K here has a charge of +2. So X has to have a charge of -2. That is group 16.
And that was the only spot that was left there.
Also.
Well, no, there were other spots here, but this is where it has to go because if K is a +2, this has to be a -2.
In the
Oh,
family.
Yeah, it's the only spot where you can put that.
Oh,
It would be
the
minus.
reason it went here is because this said that it was in the second period.
Yeah.
Yes.
So it can't be like it can't have a charge of 2.
This is
No,
where it
it
has a
would be
charge of
metals.
-2.
They would both be 2 metals,
No, 2 would be over here in this family.
and that would be 2 metals.
Correct. Yeah, you can't put 2 metals together because also +2 and +2 does not equal 0. So that's why it has to be the -2. Okay, I see what you're asking me now. Sorry. Okay. NN has an atomic number of 30. PP has 39 protons. Pretend that D and F orbitals do not exist for this question only. So what I expected you to do is count to the 30th element. 2, 10, 18, 26, 27, 28, 29, 30. So this is where NN goes, 38, 39. This is where PP goes. But we ignored D's and F's, so it was a straight count. Questions? All right. Now Q, R, and S are arranged in order of increasing atomic radii in the 6th period. There are only 3 elements left here. Okay, what happens to radii as you go across the periodic table? Okay, so the order that they are written here needs to be reversed. In other words, S, R, and Q. Because the other way is the order of increasing radius. Q, R, and S. Questions? QQ is a 5th period alkaline earth metal. Here are the alkaline earth metals. Here is the 5th period. This is where QQ goes. RR is also a 5th period element and it has a larger atomic radius than SS, which is also a 5th period element. Okay, so what does that mean? There's a 2 spots left here. Which one has to go first? Now it makes no mention of ionic radius because it doesn't need to. They're both on the same side of the line. Okay? They're both on the same side of the metal-non-metal line. an atom of VV is bigger than ZZ. So where would VV have to be compared to ZZ? Below it. But it's smaller than AA, which means that needs to be after it. This is the only spot left.
Oh.
Okay? To be bigger than ZZ, you need to be below it. To be smaller than AA, you need to be after it. If you went down another family, it would be bigger than AA because the only way you become smaller is by going across the period. WW and XX are right next to each other on this periodic table. But WW has 25 more protons than XX. The only spot that's left is down here. Period 6 was already taken, so we couldn't do it there, ladies and gentlemen. So it has to be in period 7, and WW has 25 more protons, so it goes second. H and I are two of the heavier elements. Okay, so do I put it up at the top or down at the bottom? Down at the bottom. H is more malleable, which means H is more to the left. J has a higher third ionization energy than YY, OO, or TT, which are in the same period. So third ionization energy, the noble gases are the first, alkali metals are the second, the alkaline earth metals are the third, so this is where J goes. OO is between TT and YY. YY is considered more metallic. Now, YY is a non-metal, right? But if you're going to say it's more metallic, that means it has to be toward which way? Toward the metals, toward the left. YY, TT. There you go, ladies and gentlemen. Questions?
The only ones I got wrong was H and J and the U.
Any questions?